Now we'll do an example. We're going to consider potassium diffusion through a membrane. So the question is, the diffusion coefficient for potassium ions crossing a cell membrane is 1 by 10 to the negative 16 meters squared per second. How many potassium ions per second will move across a membrane of thickness 10 nanometers and area 100 by 100 nanometers if the concentration difference is 0.5 by 10 to the power of 3 moles per cubic meter? So how do we solve this problem? A good start to all physics problems is to write down the known properties. So we've been given the concentration, and we haven't been given C1 and C2, but we've been given the concentration difference. So this is already C1 minus C2. So we can write down that the concentration difference equals 0.5 by 10 to the 3 moles per meter cubed. The membrane thickness is 10 nanometers. A nanometer is 10 to the negative 9 meters, so we can write 10 by 10 to the negative 9 meters, and this of course is delta x. And our diffusion coefficient equals 1 by 10 to the negative 16 meters squared per second, and this is d in our equation. The second thing that's often useful to do in physics problems is draw a diagram. This can be helpful to solve the problem. I'll draw it here, even though it's very simple. Our membrane is the delta x. The next thing to do is write down any useful equations. Here we need Flick's law. And finally add in the numbers, paying special attention to the units. So if we put the numbers in this equation here, we can see that this calculates out to 5 by 10 to the negative 6 per mole per meter squared per second. Now, reading the question carefully, it asks us for the number of potassium ions per second. What we've got here is not the number of potassium ions per second. We've got per unit area, and it's in mole. So now we need to use the area that we were given in the problem, which was 100 by 100 nanometers, and work out the total number of ions passing through this area. The total number passing through this 100 by 100 nanometer membrane per second, N, is just the flux J multiplied by the area A. This multiplies out to be 5 by 10 to the negative 20 moles per second. Finally, we have to convert to ions per second, and we do this, of course, by multiplying by Avogadro's number, Na, which equals 6.02 by 10 to the 23. If we multiply those two numbers out, we get 30,100 potassium ions per second.